Hello everyone. In this lecture, we continue to work with Pandas library and focus on DataFrame manipulation. Let's go over a couple of review quizzes. The first one is a true or false question. Assume that variable data refers to this data frame, which has three columns, time, x, and y. The expression data 4 through 10 evaluates to, so the result is shown in this table. Now we want to see if this result is true or false. So data 4 through 10 means that we need to start from row 4, which is our fifth observation. And what we have here is row 5. So the point is that each row is assigned an index, and the first row by default is 0. So what we see here is not the right answer. So this one is false. The other review quiz, we want to create a file data.txt. So we want to create a text file with the following content. We load the file and assign column names arbitrarily and use DataFrame as a data structure. So last time we talked about how we can read data from a text file and then save the information in a data frame. So now we are going to repeat this for this data, and in this lecture we apply different functions and manipulate this data frame. Okay. So let's create a text file first. So I open a notepad file and I'm gonna copy and paste these numbers. So when we copy and paste, we can see that there are 3 columns and 4 rows. And we can see also some commas. So we need to split data by comma. So let's save this first. Data.txt. Close it, and then we need to upload the data here. If we open it, then it's the same text file. Okay. First, we import 3 main libraries we may use: random, math, and pandas, the important one. So we have 3 columns. I'm going to define 3 empty lists. So x, y, and z, 3 variables. This is a text file. We need to open the file first. This data.txt, and we are in reading mode. Then we need to write a for loop to go through all lines. So I define a variable named items, line.split. So this time, because we have commas, we need to split the numbers by comma. Before we split them by space, but here we split it with comma. That's the difference. And then we can use the append method to populate lists. So x.append items. So the first element in this list goes to x. The second element, items 1, goes to y. The last column is assigned to variable z. Let's run this. Oops, we need a parenthesis here. Okay. So append parentheses, and I'm going to make sure that we change the data structure to float so we can apply arithmetic operations as well. Let's run this. Okay. And now we can create the data frame. Put this together. Create a variable named df. We call pandas. Then that data frame. I use a dictionary to assign values to each column. The first column, I call it x, and its value is variable x. The second column, let's say, is y, and we assign y variable. And the last column is z, and the values and variable z is assigned to this one. Okay. Now we run this, and if we print, then we see the table with 3 columns and 4 rows. The first row's index is 0 by default. So we created this data frame. We first opened the text file, and now we are going to apply different function to this and manipulate this data. Okay. Frequent operation is applying a function to each column or row. So we can apply some common functions to data frame. Here, for example, you see the ABS, which calculates the absolute value. So in our data, we have some negative values, and if we apply this function, all should be positive. We can also use apply lambda method. As you can see here, we define a function, f equal lambda x. Lambda is a reserved word and the color is green. So we say the input is x, and then we want to calculate the difference between maximum value and minimum value for each column. So x.max minus x.min. So this becomes our function. And then we can use the apply method. We call the DataFrame.apply, and then we can see the result. This function will be applied to each columns by default. Now, if we pass axis equal to columns to apply as an argument, the function will be invoked once per row instead. So it calculates that function for each row. So to do that, we just need to pass on second argument, axis equal to columns. Let's implement this in a notebook, and you can see what the results look like. Let's apply the ABS function, absolute value. So you can see that y values, we have negative values. So let's see what happens. ABS to df, and when you run it, then all values under y become positive. We can also write other functions, just like the example that we just saw. F colon, I think it's equal lambda dot x the color is now green. Okay. Lambda dot x, and then x dot max minus x dot min. This is the function. Don't need a dot here. Okay. And now we can use the apply method. So we call the data frame df dot apply this function. And then you can see for each column, X, Y, Z, we have this difference, maximum value minus minimum value. For example, if you look at column X, maximum value is 4, minimum value is 1. 4 minus 1 becomes 3. And the same for other columns. Now, if we want to apply this function to each row, then we pass the second argument. So df dot apply f axis columns. Let's run this. Okay. Now you can see we have that function for each row. We had 4 rows. The first row, maximum minus minimum, then we see the result. So it applies to the original data frame. Here, maximum is 1 and minimum is minus 1.3. So 1 plus 1.3 is the result that you see here. The same for other columns. So that's how we can apply functions to each column and rows using apply and lambda method. We can also sort a data set by some criterion using built-in operation. So let's say we are working with the same data frame, XYZ, we just created, and now I'm assigning an index. So I want to assign different index to each row. By default, it's 0, 1, 2, 3, and now I want to assign B to the first row, D to the second row, A to the third, and C to the fourth one. So you can see how the sorting works. So when I update my data frame with this index, then we can apply sort underline index, and then it sorts the data. So by default, it's sorted in ascending order, but we can change it in descending order, and we just need to add one argument to sort underline index, and we make ascending equal to false. Okay, let's apply this and see what the result would be. First, we are going to update the index. If you look at this data frame, the index for each row is 0, 1, 2, 3. Now I want to assign different indices. So I call pandas data frame. I use the same dictionary, X, Y, and Z, comma, I define index for each row, which is a list. So the first one is B, third one is D, the third row is A, and the last row is C. So let's run this and let's see what the data frame looks like. So now you can see the index for each row has changed based on what we defined, B, D, A, C. And now if we apply the sort function, it sorts the data frame for us. So df dot sort underline index. When you run this, you can see it is sorted in ascending order, A, B, C, and D. Now, if we want to see in descending order, we just pass one argument. We make the ascending false. So df dot sort underline index, and ascending is false. And if we run, then you can see that D shows up in the first row, C, B, and A. And that's how we can sort a data frame based on their index. We can also summarize the data frame using descriptive statistic. Minimum values, maximum values, number of observations for each column, average values, or a standard deviation. Pandas objects are equipped with a set of common mathematical and statistical methods. Most of this fall into the category of summary statistics, methods that extract a single value like mean from rows and columns of a data frame. Here you can see the sum method. Sum method returns a series containing column sums. So it calculates the summation for each column. So we call the data frame, then apply sum. If we pass axes equal to columns, then it sums across rows. Otherwise, it sums across columns. Another useful method is describe. Describe computes set of summary statistics for series or each data frame column. In your project, in your homework assignment, when you want to summarize a data set, we can simply define data frame and apply describe methods. Then you can see the descriptive statistic in one table. Let's try to run this for the data set that we have, and you can see the result. Let's apply the sum method first. df sum, and then it calculates the summation of values for each column, x, y, and z. Now if we want to calculate the summation for each row, just like before, we pass axes. So df sum axes equal to columns. Now you can see for each row B, D, A, C, then we can have the summations. So this is the new data frame with the index we just defined. So we have negative values as well. Now if we apply the describe method, df.describe, then you have this table. So for each column, you have count, minimum value, a standard deviation, minimum 25% quantile, 50% quantile, and 75%, and the maximum value. So you can see that for each column, we have 4 observations. We have the mean value, a standard deviation, mean, and max. And that gives you good information about the data you are working with. So describe method is very useful for summarizing descriptive statistics. In this table, you can see common methods that we can apply to data frames. Count returns number of non-NA values, non-available values. Mean or max compute minimum and maximum values. Argmin and argument max compute index location at which mean or max value obtained. And median calculate the arithmetic median value, and MAD is mean absolute deviation from mean value, and prod returns product of all values, and STD is a sample, a standard deviation of values. So these are the common functions you can use for summarizing your data. Another interesting feature is analyzing group data. Refer to salary text file that we analyzed last time. So we had 4 columns. The first column was employee's name, their salary, and number of years they were with the company, and the last column was gender. Now, the following code produces descriptive statistic, like what we just saw, for group data based on the gender. Let's say first we want to group data based on the gender and then produce a descriptive statistic. The method that we use in this case is called group by. So I define a variable, then call my data frame, then apply group by. And we pass on the column. So you want to group by which column? So column 6 is a categorical variable in this case, and that's why we can use that to group our data. And once we create that variable, then we apply describe method and we list descriptive statistics. Let's see what it looks like when we run it in a Python file. Okay. So this is the salary data set that we discussed last time. So we run this, we create the data frame, and this is our data set. 4 columns and 25 observations. Now we want to group this data set by gender, the last column. So we define a variable grouped, call the data frame df, and we apply group by method, and then we pass on the name of the last column. Let's run this, and then we can apply the describe method. So grouped dot describe, and then we can see descriptive statistic. So first off, you can see there are 2 rows based on categories we had in the last column, female and male, and then we can see the descriptive statistics for salaries and years, right? So count, mean, standard deviation, minimum value, and maximum value, and the same for years. So with group by, we first group them based on their gender, and then we look at the descriptive statistics. Later on, we will use this method to visualize the data using group bar plots. So we are going to use this group by a lot. Another feature for manipulating data frame is subsetting the data. Sometimes we want to subset rows or columns of data frame according to labels and the specified index. I'm going to talk about 2 methods here, filter and query. So we can apply filter to our data frame, and there are 2 input arguments, items and regular expression. The items and regular expression parameters are enforced to be mutually exclusive. So if we use items, we don't use a regular expression. So items can be columns, and regular expressions can be any expression which search for the defined condition. And you're going to see an example. For instance, we can search a substring. With query, so we can apply query method to the columns of data frame with a Boolean expression. So we define the expression here, we apply query, and then it returns the result. So here's the example. When you see the example, it makes better sense. Again, refer to the salary dataset that we just discussed. And now we want to apply filter method. First, we use items, and then we use a regular expression. Items, let's say we want to choose 2 columns, salary and years. And then we filter the data. Or we want to search a substring. We want to search any string starting with SAL. We know that in our data set we have salary, so we expect to see at least 1 column. For query, let's say we want to find employees who have been with the company more than 10 years. So this would be our Boolean expression. df.query, then apply or refer to years, the column, such that their values are greater than 10. And then we can see the result. Let's implement this. df.filter, then we have items, 2 columns, let's say salary and years. Now this is the result. Then we have all observations for these two columns, all 25ths. Or we can apply regular expression. Filter. Regular expression is substring sal and with asterisk. So anything which is start with SAL. Let's see if there is. Okay. Now you can see we only have one column which matches this expression, salary, and then we filter the data for this expression. We can also apply query. So there is a method named query, and then we want to focus on this column, years. So you can see that we have employees with 2 years with the company, 4 years, 1 year, 25. Now let's say we just find, we want to see employees who have been with the company for more than 10 years. So this would be the expression, and when we run it, so we see all 4 columns, but under years, we only see numbers greater than 10. For example, 0, 1, 2, 3, 4, or 5 are excluded. So all numbers are greater than 10. So this is a subset of our data based on this expression. So in summary, in this lecture, we discussed functions that can be applied to each row or column of data frames, some common mathematical functions. We also discussed methods for sorting data frame in ascending order or descending order. We also discussed this describe method, which generates descriptive statistics for the data frame. We briefly talked about analyzing group data using group by method and how we can subset the data or partition data sets and write queries using Boolean expressions. With that, I wrap up our discussion about data frame manipulations.